Thanks, Fist. Yeah, I'm really excited about this talk. I think it's going to be fun, and I hope to stir up everybody's imagination and inspire people. Maybe developers will literally just take an idea that I discuss and build it, or an entrepreneur will put something together, or I'll give you some idea of a primitive that you can build something from. Everybody can get something out of this talk. It's not just for developers. I just want to explain some like tools that we have to build on Handshake and expand the protocol. And then I'm going to discuss some ideas that I'm aware of from developers that I speak to every day. Yeah, so let's just jump into it. This is the future and fantasy of Handshake. Oh, let me share my screen. Share screen, screen one. All right, you guys can see that. Just somebody say what up in the chat so I know that you guys can see the slides. This is my usual starting place. Okay, great, thanks. So I hang out in this Telegram channel. This is not the only think tank in Handshake. I don't want to act like this is the core team or anything like that. I just want you guys to know this is my perspective on the development community, and the ideas that I'm going to discuss today come basically from this group of people. And maybe, hopefully I didn't miss anybody, but the people who are most active in the Telegram dev chat, this is the crew. And if you like any of the ideas, or if you have a new idea, come and join us in the dev chat. And even if you're not a developer, if you're a UI person, or an entrepreneur, or a domainer, or a translator into some language, come on into the dev chat and work with us and help us make some things happen. Now, on the topic of ideas, we have something called HIPs, Handshake Improvement Proposals. We've based this off the BIPs, Bitcoin Improvement Proposals, which I think in turn was actually based off a Python improvement proposal system. One of my favorite quotes is from Peter Willa, who basically said that the BIPs system is just to assign numbers to ideas. That's it. They don't have to be good ideas. They don't have to change. We don't have to actually develop them. We don't have to actually do what the idea says. If it's like a protocol change, like a hard fork or something, the idea is just to have some kind of reference and a standard. We're up to about 9 so far, and some of these have been discussed this week already. This website that you're looking at is actually sourced from a GitHub repo, which is really, if you have a Handshake improvement proposal to propose, you would open a pull request to this repository, and there's some instructions here on how to do that. There's also this discussions tab, which I want to display really quick, and these are like the half-baked ideas, or the oven. They're not really formal proposals yet, but some people have an idea or a question, and they can start a discussion here, or in the Telegram chat. Flesh out the idea, and then when it's ready, open a pull request with a formal document like one of these, and specify your idea so that everybody knows what it is. We give it a number, and then we can talk about it at HandyCon next year. Okay, so let's talk about some of the ideas. What I'm going to do is the first couple slides, I'm going to talk about like the primitives, ingredients that we have to cook up these ideas, different elements of Handshake to get you thinking about like, oh, maybe I can do a piece of this with a piece of that. That's how I want you to think about these ingredients here. These are the Handshake covenant system. Most people probably recognize most of the words on the screen. This is a slide from other talks I've given introducing Handshake. So I'm not going to spend too much time on it, but there's the auction process on the left, and then there's the transfer system on the bottom right, and the register, update, renew. So we have these covenants, and the covenants restrict the spending of a transaction. You basically have to follow these arrows, and so that's kind of an interesting burden to put on transactions on the Handshake protocol. So for example, like if you want a transaction that's only valid for 5 days, let's say I'm going to send you money, and I'll send you this transaction, and I only want you to be able to broadcast that transaction sometime in the next 5 days. Well, one easy way to do that is to add a bid for some random name. It doesn't matter. It could be a bid of 0. But everybody knows bidding is only allowed for 5 days, right? Otherwise, that transaction is not allowed in the blockchain. It's invalid. So that's the kind of thing I want you guys to think about. Like, you already know how covenants work. Can you take a covenant and do something wrong with it, do something weird with it, or incorporate it into some other system to apply these extra rules in a way that maybe the founders didn't expect? Oh, and speaking of the founders, one thing I definitely wanted to mention when I was talking about whoever you are, come join the dev chat. Joseph Poon, one of the founders of Handshake and an important designer of the protocol, is not a coder. He's not a developer. but he has great ideas and, invented the Lightning Network with the help of a developer. So just be inspired by that. Whoever you are, you can have ideas. Okay. Covenants, great. Sorry. These are the opcodes. So when you create a when you spend a transaction, you have to spend something you already own. You either own HNS coins and you want to spend them to somebody else, or you own a name and you want to update it or transfer it or something like that. And to do that, you need to write this little program into the output of your transaction output. And your wallet will do this automatically. Sorry. Most of the time, what our wallet is doing is it's using opchecksig, which is in here somewhere. It's in here somewhere, I promise. And that just means I give you a public key, a signature, and you check the signature. And if it's a valid signature, then you're allowed to transact. But it doesn't end there. There's, I don't know how many there are here, maybe 100 opcodes. They're all from Bitcoin, except for the ones in green on the right. These are new that JJ added to the Handshake protocol. There's a couple extra hash functions that we use in Handshake that Bitcoin does not use. And we also have optype, which is very important. Optype is an opcode that takes the covenant from the transaction output, puts it on the stack. And I'll expand on that later. And the ones I have colored in red here are actually disabled. They were added to the protocol by Satoshi Nakamoto and then removed from the protocol by Satoshi Nakamoto because of different attack vectors. So, it's not Ethereum smart contracting. There's no loops. There's no persistent memory or anything like that. But there is a lot of stuff going on here. You can do a lot of weird stuff with math and moving pieces of data around and comparing numbers and hashing things. And you can have if logic, if then logic, and you can add as many signature checks as you want. And you can have a really interesting output script that's not just public key signature. Sig hashes are super interesting and is a kind of a crazy subtlety of that we have inherited from the Bitcoin system. So this is a Bitcoin transaction, just because it was a convenient screenshot to take, that has 2 inputs and 3 outputs. The 2 coins on the left are being destroyed or spent. The 3 coins on the right are being created. Take the money on the left and send it to the people on the right. So the signatures in this transaction, you might not think about it, but what do you actually sign when you sign a transaction? And the answer to that is it depends on what you want to sign when you sign a transaction. Oh my God, look at all these colors. There's lots of different ways to sign different parts of a transaction. You can see the big red square that says all. Most of the time when you send a transaction on the network, you're going to sign the entire transaction, but you don't have to. If you've ever used ShakeDex or if you've ever used the atomic swap feature in Bob Wallet, you have used single reverse, the weird orange one that signs the top on the left and the bottom on the right. And there's other weird constructions here too, weird ingredients. No input is one that was proposed for Bitcoin, but still does not exist on Bitcoin, but JJ added it to Handshake, which is one of the kind of nice advantages we have of starting a brand new project. And the reason you would sign different parts of a transaction instead of the whole thing is to collaborate with other people. So I could start it, like I mentioned, like the way ShakeDex works or the way atomic swaps work in Bob Wallet. I can sign, one input and one output of a transaction, and those cannot be mutated. They are signed. They're done. They are done. And then give it to you, and you can fill in the rest of the transaction by either signing all or signing other pieces. So just something else to keep in mind. We can combine, we can work collaboratively on a transaction by signing different parts of it. Wallets. Wallets work like this. I love this diagram. It's from BIP32, back when hierarchical deterministic wallets were made. Don't drool at this image. Don't worry about it. You know what this image is. What this image is your seed phrase, the 24 words that you wrote down when you installed Bob Wallet or when you got your ledger. That's over here, the S, little dots, it says entropy 128 bits. That's your seed. And what this diagram is showing you is basically that you can generate an infinite number of addresses that are subdivided into an infinite number of accounts. If you're a Bob Wallet user, you probably don't realize that you're doing this. You get a different, most people observe that they get a different address every time they use an address, even on Namebase, because Namebase uses this too. This is how hsd works. But you can also have accounts, and And this is something that you wouldn't notice by using HSD or Bob Wallet. But if you are building a service like an exchange, like if you are Namebase or Purse.io, you with one seed phrase, you can create accounts for billions of users, and each of those billions of users can have billions of receive addresses that always work forever, and they can get new ones every time. So this is great. Just you back up one seed phrase, and you have all these addresses that can be organized in lots of different ways. All right. So the last thing I'll mention as far as ingredients to these two new ideas are protocol upgrades, hard fork versus soft fork. These are words that we're going to toss around a lot. If you want to change something about how the core protocol works, something like about Handshake in general. And when we talk about forks, what we basically mean is we are changing the protocol rules. And there can be a hard fork or there can be a soft fork. And the difference between those two is basically backwards compatibility. And what I mean by that is how many, what kind of software that exists today will still work tomorrow after the fork. And that's the rule. A hard fork, 100% of all nodes must upgrade. Every exchange, every registry, every Bob Wallet user. In some cases, if it's a hard enough hard fork, users using Fingertip, hnsd, the Bob Chrome extension, SPV nodes, iPhone apps, might also need to be upgraded. A hard fork is hard to do. Bitcoin, for example, has never really, arguably, but basically never had a hard fork. Some other cryptocurrencies certainly have. Bitcoin turning into Bitcoin Cash, that was a hard fork. It's incompatible with the existing system. They broke a rule so hard that it created a whole new chain. And we can do that if we want to. Examples would be increasing the money supply. Increasing the money supply. I also, some people like to have the idea, like, why don't we take ICANN's, whatever it is, 24 million HNS tribute and just give that to developers or something. That would be a hard fork. It's not technically increasing the money supply, but we are taking money away from somebody. That is breaking the protocol. That would be a hard fork. Everybody would have to change their software. Otherwise, that would look like a very invalid transaction, which is a good thing. Extending the reserve name claim period. This is a hard fork that will probably happen if we can write it and do this community organizing thing that is required. So the reserve name claim period lasts 4 years. Google, Apple, Facebook, com.info.org, they can reserve their name. They only have 2 years left to do so. If we want to extend that and still let them claim their name, that is a hard fork because right now all the Handshake software out there thinks that this name claim period is going to end after 4 years. And if we start allowing them to claim after that, the software that exists today is just going to barf. No, that's invalid. And then we have a chain split, and then there's 2 handshakes, and it's bad. But we can organize it and do it right. Changing rules for existing covenants, names, and Urkel tree data. These are all hard consensus rules. If you want the reveal to do something else, or if you want to be able to finalize a name without a transfer, that's hard fork. The rules that exist have to stay put, or we need to change everything. Soft fork. 50% of miners must upgrade. Basically, what happens in a soft fork is that miners censor the network, and that could be a good thing. Segregated witness on Bitcoin is a soft fork. Taproot on Bitcoin, soft fork. Even pay to script hash on Bitcoin was a soft fork. Sometimes it's hard to think about how backwards compatibility works, but that's it. And you basically just tell the miners to censor certain types of transactions. And then everybody who runs full nodes keeps the miners in check, make sure they're doing that correctly. Handshake has already had a soft fork, as JJ mentioned the other night. It was a covert soft fork because it was fixing a very bad bug we didn't want anybody to exploit. So unfortunately, we could not include the community in discussing the soft fork, because if we told anybody how the bug worked, people could exploit it immediately. So this is kind of interesting. Okay, so that was a soft fork that was designed by 2 engineers and deployed directly to the miners without including the community. And I'm sorry we did that. That's tough. It was a tough thing for us to do, to have to keep a secret from the community. It's hard stuff. But anyway, ideally, soft forks involve the community. We all decide that we want to do it, and people don't have to upgrade everything. We just need to get the miners to upgrade, and then Like, so, all right, so let's talk about them. So name claim inflation bug fix is a soft fork. Adding new covenants and witness versions are soft forks. So we already have our covenants set back here. We all know these covenants. Let's say you wanted to add a new covenant like update 2, bid 2. Maybe you have another covenant type called pancake that does something weird, or whatever. Use your imagination. Please use it. Imagine something. New covenants can be added to Handshake as a soft fork. That means that only upgraded software will know what to do when they see those covenants. Old software will simply ignore them. Okay, that's cool. Reducing the money supply again is a, I don't know why we'd want to do that, but we could. That would be a soft fork. Old software wouldn't care if the money supply was reduced. They wouldn't even realize something had happened. All right. Oh, and finally, DNS records. I just put this in here because it's another ingredient. We have, this is a cool diagram of all the main DNS records. A lot of them you're already familiar with, I hope. A records, TLSA, we talk about a lot. The DNSSEC family is over here on the bottom left. And, this is part of Handshake, is what can we do with DNS as we come up with different ideas to expand Handshake and stuff like that. All right. Let's start talking about some of these ideas. I'll check for questions real quick because I know that I was lecturing. Okay, and I'll get to these later. So let's talk about some of the ideas that the developers that I'm aware of that I talk to have come up with. Again, these are not all my ideas. Most of them aren't at all. They're just ideas that I'm aware of that have not been made yet. Maybe you will make some of these. Role-based wallets. So it's similar to Multisig. You might be familiar with Multisig already. Some of you might even have used it. It's kind of advanced, but it is possible to use Multisig on Handshake right now. The idea is you own a Handshake balance, an HNS balance, or a name that requires some multiple amount of signatures to spend or to update. And this is very common in Bitcoin, and it's a good security measure too. You can imagine even having a multisig with your Bob wallet and your ledger, where you needed a signature from your laptop and your ledger device to move your own money. So you could have a multisig just by yourself. Well, we can expand that with optype, which I mentioned on the opcode slide. And you can, and this is actually mentioned in the white paper, which is why optype is so cool and was an idea that JJ and Joseph had in the very beginning. You can have a wallet where Bob Wallet on your laptop can update your DNS records on the root zone, but you still need your ledger to do things like transfer, finalize, revoke. And this is what I mean by role-based. So, or if you're a company and you have employees and you're managing domains, maybe you're in Circa, maybe you have the TLDs that you control. Transfer, finalize, revoke requires a 3 of 5 multisig from the board of directors. And then you have supervisors that can do things like register names after winning auctions or update DNS records. And then you have another group of people, like employees, that can bid and reveal. So you can have a room of 20 people where 10 of those people are allowed to bid on auctions and reveal. But only the 2 supervisors can actually register once the auction's done and update the DNS records. And then finally, there's only the CEO and the VP of tech. They do a multisig if they ever need to actually transfer, finalize, or revoke. I don't know. I think that's just super cool. And we can build this software now. Nobody's done it yet, but it's possible. What else we got? Okay, federated, not quite decentralized TLDs. I've been pitching this. Everybody's talking about decentralized SLDs or things like how Forever and Bob and Badass work. How we want to have decentralized zones, and it's hard because right now we're using Ethereum to do that. I thought Luke Burns' talk was great about using IPFS. I also agree with him that DNS records don't belong on chain as much as possible. So I think that's cool. So we have this idea of, and people keep suggesting let's use side chains for each TLD, and you have a side chain that manages the SLDs. It's getting complicated, okay? It's getting hard. We want people to be able to access these domains easily without having to verify the Ethereum blockchain. So federated means that there is a large group that control a TLD, and they may not have to trust each other at all. So I guess, is it decentralized? If you have a federation, it's not really decentralized. It's distributed, or anyway, it's federated. So imagine that we have a name that's owned by a multisig wallet. Let's say it's, I'm just going to pick people from the questions. It's me, Aaron, and A. The three of us form a multisig wallet that requires all three of our signatures. We'll call that a 3 of 3. And we bid on some names, and we own some TLDs, and we can update the root zone records. All three of us have to sign. Now, right off the bat, something that's interesting about this is that if somebody else wanted to join our company, let's say Mike wants to join our company, we can include him in a new multisig policy that's 4 of 4, or maybe it's 2 of 4 or 3 of 4. We can all decide, and then we transfer all the assets to that new address. And now Mike is part of that group, you know. So what you can do is basically have like a co-op where everybody who owns an SLD owns the TLD. So you like, okay, you've got a great TLD. It's .hotdog. I want to own ketchup.hotdog. I'll pay you $1,000 for ketchup.hotdog. And that money gets split among the current owners of .hotdog. I get the SLD ketchup.hotdog, but also my key becomes part of the multisig, and I own part of that TLD. So you can add people to the policy like that. And then where it gets really interesting, and this is where I have to get a little hand wavy because the cryptography gets a little, I don't understand it entirely, but I know that these ingredients are possible, especially, you know, with like with Schnorr signatures and stuff like that. Multisig DNSSEC, okay? So if 5 of us own a TLD and we don't trust each other, we can each run our own name server and put NS records for all 5 of those name servers in the root zone, and then even put DS records where each of us has a key and put all those in the root zone, and all of us would have valid name servers, and we'd all have a copy of the current zone file, and we could basically all keep each other in check. And in that way, a group of people who may or may not entirely trust each other can participate in the operation of a TLD, basically in a decentralized way, in a trustless way, that the SLD owners don't have to trust the TLD owner because you are part of the TLD ownership. And there's ways to do this and then to make it even more interesting. So what I have here, Threshold EC or Schnorr or Key Edition like Multisig, is that instead of multiple NS and multiple DS records, there is a way to combine our keys and create a single public key and create a single signature, so we can have a zone file that's signed by what appears to be one key, but is really a combination of everybody's keys. And that's just awesome. And if we ever get to something like merging Taproot into Handshake, that kind of idea can get much more interesting and maybe even simpler. The other thing that's part of this, no, I'm going to talk about that later. Okay. Yeah. Okay. Cool. Federated TLDs. We can come back to some of that stuff too. SLDs on chain. All right. Everybody loves to talk about second level domains on chain, third level domains on chain. I sort of agree with JJ's kind of like, I don't really want to do that sort of reaction. I feel like he had the other night. I mean, like, let's see if we can get this root zone thing to work first. The other thing to consider with all these protocol improvements is scaling is super important to us. The light client has to work. We want people to be able to run full nodes like Bob Wallet, or just, you know, full nodes on cloud servers. Keep in mind that some hard forks of Bitcoin, like Bitcoin SV, have like gigabyte blocks, and basically nobody runs a full node. So it's just simply not decentralized. And that's a spectrum, you know. If we allow too much data on chain, then the burden of running a full node or validating the chain with a light node gets harder. And so we need to be very careful about those trade-offs. But anyway, so let's talk about some ways we could put SLDs on chain. Like I said, the idea doesn't have to be good. I just want to inspire some creativity here. One way to do it would be with a second set of covenants and a second Urkel tree. So right now we have, like I said, the set of covenants like bid, reveal, transfer, finalize, and there's one Urkel tree, and we can't really change anything about that without a hard fork. But we can add a complete second set of covenants and a complete second Urkel tree. And have a whole second auction system on chain parallel in addition to the existing one, with new rules about how bids and reveals work and how transfers work, and how whether the auction winning price gets burned or sent to somebody. These are kind of rules we can actually add, and we can actually add a second Urkel tree. And because it's a soft fork, it could be opt-in. If you're running Bob Wallet, you don't have to do this. You could opt out. You could not have that second Urkel tree. You can ignore the second set of covenants. So that's cool. Hard fork. So there's one proposal. I think the user's name was Vlad in the dev chat, and he was talking about how to SLDs on chain for TLDs that are already on chain. And one of the interesting parts of the hard fork is adding dot in handshake names. So dots are not allowed in handshake names. It's just letters, numbers, hyphens, and underscores, and hyphens and underscores are not allowed in the beginning or end. That's the rule. And 63 characters long. Those are the hard rules. If we want to break any of those rules, we're talking about a hard fork, and everybody's got to basically reinstall new software. So if we're going to do a hard fork, what if we allowed dots in handshake names? And then the dot would have this special property where the string to the right of the dot would have to be a handshake TLD that already exists and is already, let's say, configured with the anyone can renew script, the way Badass and Forever work. And then people could open auctions. So I could open an auction for mattzipkin.c. That would happen on chain. That would require a hard fork because dots are not allowed in handshake names. Problems, yeah. What do we do with the purchase price in the hard fork example? I'm kind of waving my hand at it, but those prices would probably be burned. Scalability, I already mentioned. Okay, SLDs on chain, lots of other interesting ideas there. Bob Wallet zone management is one that I'm 10 minutes, thank you. Is one that I'm really excited about, and I hope somebody builds, and I might build it myself maybe later this year because I think it's going to be a really good idea. Imagine if you could just configure your zone file in Bob Wallet. Or people are always asking this. It's a frequently asked question. How do I add SLDs in Bob? How do I add my A records in Bob? A lot of these users are asking that because they don't realize they need a name server. So, okay, what if there was a federation of available name server service providers? Let's say services provided by Kyocon, Namebase, Sympapelis, HS Hub, Impervious, Nyami. Everyone who you know can offer the service for a small fee. And the service is, if you send me your signed zone file, and $1 per month, whatever, I will serve it. And you can put my name server in the root zone as your NS record. So that's one component of this. The other component is back when I was talking about how we can generate keys from your seed phrase. You already have your seed phrase back up, right? Everyone's got their seed phrase backed up already. And that'll generate all the addresses you'll ever need in Bob Wallet for the rest of your life. Well, we can also use that seed phrase to generate DNSSEC keys, which means the flow in Bob could look like this. You go to Bob, you go to the domain manager, you pick a name that you want to add SLDs to or add DNS records like an A record to. You get a window and you type the A record in, or you say, mattzipkin.hotdog has this A record now, and you click go. And what happens is Bob derives the DNSSEC key from your wallet seed, signs the zone, uploads the zone to Impervious, Kyocon, Namebase, Sympapelis, HS Hub with a 1 HNS fee attached to each of those, puts the DS record and the NS record for each of those services in the root zone all in one click, and that's it. It's like it could be just that simple UI. Bob Wallet users don't need to understand DNSSEC. They don't need to run their own name server. They can just be a window in Bob to add records to the zone. And this is also an income stream potentially for these service providers. And it's trustless because you're signing your zone. If one of the service providers go down, you just don't pay them the next month and you use one of the other service providers. I mean, we could have a free market there. I wrote Bob Wallet could even periodically do DNS requests to your own zone to make sure that the records are being served by Sympapelis, Namebase, and Kyocon, and alert the user like, hey, Namebase is not serving your zone anymore. I'm going to stop paying them automatically. All right, I'm really excited about that one. Okay, turbo blinds, lockup loans, staking. My friend Anu in the dev channel has taken point on this, but it's been a long discussion. Namebase, I think, was discussing this thing called turbo blinds. The idea is to thwart snipers by borrowing a huge amount of money. So let's say I'm Bob and I've only got 100 HNS to bid on the name Bob. I don't want to get sniped because that's a good snipey range right there. So I borrow 1 million HNS from Alice. She actually places the bid on chain and nobody bothers sniping because it looks like there's 1 million HNS bid. And then in the reveal, it turns out that it's really only my bid of, 100 HNS. And then Alice gets her 100,000, or what did I say? Alice gets her 1 million HNS back plus a small fee. And that's how we want it to work. And one of the other frequently asked questions we get from people who kind of wander into the handshake space is like, how do I stake this coin? Because everybody's into DeFi. This is kind of a way to do that. If you have a bunch of HNS, you could loan it and make interest this way. It would be very easy to do this on a centralized platform. Fernando Fauci described it as something he wanted to add. I think it was, yeah, to Sim Papeles. We can also do this in a decentralized way using those cool transaction primitives I showed you earlier. The way it would work is that Bob and Alice would communicate a few rounds in advance and exchange some public keys, and then Bob would make a transaction to Alice on chain that just looks like somebody sending money, and it would be his bid plus the interest that he's paying Alice, and that transaction just sits there and looks innocuous. And then later on, during the bidding phase of an auction, another transaction appears on the network that is the huge bid. And these transactions must not be linkable, otherwise the game is up, right? What we're trying to do is to trick snipers into thinking that that this huge bid is being placed, when really it's my tiny 100 HNS. And at the same time, we need to protect both Alice and Bob. Bob needs to win his name. Alice needs to get her money back. So we need to do these interesting like Lightning Network type transactions with lock times and stuff like that. And then in the end, in the reveal, the outputs of those two transactions I mentioned get merged, and everybody can see that it was a lockup loan, but it doesn't matter because we're in the reveal phase. Alice gets paid her fee. She gets her stake back. Bob either wins or loses the name, but either way, he never had access to Alice's whale account. And anyway, very cool. Could be decentralized. Could be a staking method. I hope somebody builds that. Let's see, how much more time do I have left? I got a couple minutes. I'll talk about DNS stuff really quick. My colleague Buffer has done some really cool stuff with Beacon. You might not realize it, but he's kind of invented something called PowDOH, proof of work DNS over HTTPS. The way that fingertip works is that it does all the DNS resolution locally on your computer. It's a recursive resolution. But we've discovered that that's not always possible. Sometimes you're at a hotel Wi-Fi, or even your own internet service provider will just block port 53, and then you just can't do DNS resolution. So what Buffer has done in Beacon browser, and especially on mobile devices, by the way, it's hard to add extra DNS stuff on mobile devices. So what Buffer's done is he's invented this idea where you have hnsd, and it doesn't actually do the recursive resolution. You have hnsd on your phone, that's true, and it does sync the block headers, that's true. But all it actually gets from the Handshake root zone are those DS records, the public keys, the roots of trust. Then it can ask some external recursive resolver using legacy HTTPS with a legacy certificate for the A record of the website you want to go to. And it's sneaky because it's HTTPS. It just looks like every other type of web traffic. You don't need to trust that recursive resolver because you have the DS record verified. You verified the proof of work already. This is already how Beacon works, and we're already talking about ways to make this even cooler. One way would be for the web server to actually provide proofs of their own DS record in the root zone. What this would mean is that all the light clients out there would not need to burden full nodes as much. They wouldn't need to be requesting Urkel proofs. The downside to this is that people who run websites would need to basically run some type of handshake node on their own web server. They need to be able to obtain their own proofs to serve to the client. And then I had an additional idea, which is, well, what if we serve the block headers too? You basically wouldn't need hnsd at all. What I could do is give you the Urkel proof with my DS record, and then give you maybe 20 handshake block headers that bury that proof. And that'll prove to you that it took some group of miners so much electricity to create this proof, which creates the chain of trust that creates the DANE, blah, 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 blah. And if that cost is acceptable to you, you can assume that those headers are actually in the main chain. I don't think handshake mining activity is efficient enough for this to be totally safe, but it's an interesting idea. And I stole that idea from James Presswich, who wrote an article about it a few years ago about proving that a Bitcoin transaction has occurred to an Ethereum smart contract using the same kind of thing. That's just called stateless SPV proofs. We also, Buffer and I have also discussed onion routing. Onion routing is Tor, recursive resolution, maybe using other HSD peers. Maybe, as we're connecting to other handshake full nodes, we can ask them to do recursive resolution, something like that. The interesting thing about, okay, I'm just looking at how much stuff I want to try to get through here. Yeah, okay. All right, lightning round. I'm going to talk about, I got a couple minutes left. Fistful said I could go a couple minutes into the break, so I'm going to talk about these real quick and then maybe take a look at the questions. Candle auctions. We're talking about randomizing the way that auctions end so that nobody knows when the bidding phase ends. That eliminates snipers. Not going to elaborate on that right now. Something about making an offer on chain. Some way to trustlessly send a transaction to a name owner without any preparation or communication from their end at all. You just get a message in your wallet one day that's like, here's an offer, and they can click it and it'll approve. They won't have to transfer names to ShakeDex or something first. And on that note, we could have wallets where all the addresses are ShakeDex wallets. So if you've ever put a name on ShakeDex, you need the 2-day transfer to put a name on ShakeDex before you can actually sell it. If all of your addresses are HIP-1 addresses already, you can bid, reveal, and register with HIP-1 addresses. You don't have to transfer to ShakeDex. You're already in ShakeDex mode. I have HIP-6, which is similar to ShakeDex, but the auction prices go up. And finally, this one is cool. So HSD full nodes actually have identity keys, and they have something called Brontide, where HSD full nodes can communicate over an encrypted channel using a static identity. If you've ever run HSD, you've seen the identity key. And this is something that we basically have borrowed from the Lightning Network, where individual nodes need to have identities because we're going to send them encrypted messages. Well, that got me thinking. That means that our own HSD nodes can communicate with each other. We could have a Lightning Network built into HSD without even adding a layer 2. It could just be part of HSD because we already have this identity system set up. Also, if we're doing atomic swaps or multisig or any of the other ideas I mentioned, like federated TLDs, we could use HSD's own transport mechanism, which is encrypted and private, to send messages to certain nodes on the network. So if me and Fistful of Ass, I have no idea who that guy is. If he and I are collaborating on a TLD together, and we both run full nodes with these Brontide keys, which is the Brontide stuff is already there. It's happening now. It works. It's running. But we can use that to send encrypted messages to each other. To, for example, I prepare a transaction, I sign it, I send it to him over HSD, and then his node can sign it on that end. We can do the multisig stuff. Okay, man, that was really fun. I hope I inspired some people. I don't know how much time I have left. I know I have like -2 minutes. Let me just take a quick look at the questions here. A few million SPV clients. Yes, I'm worried about the total number of SPV clients. Right now, I run a full node that supports about 1,000 light clients, and so I'm not totally worried about the impact of light clients on the network. But they will, we're willing to support it. Okay. Sounds like proof of work has a governance problem. Is day 0 interest illustrated? I don't really understand that. I might have to discuss that offline because I think it's going to take me a few minutes to understand the question. For the group of name server providers, are the signed zones for each TLD on chain? No. What you put on chain is, if you saw my Dane talk 2 nights ago, what you put on chain is the NS record. So you put the NS record for Kyokin's name server, Impervious's name server, Namebase's name server. And then the DS record is your own public key. And that's how people who verify the zone know that Impervious isn't sending me false data. And that's why you don't have to trust those name servers. Because you sign the data, you give it to them, and then you put your public key on chain, secured by proof of work. So the zone data does not go on chain. The only thing that goes on chain is the trust anchor, which is your public key. That's a DS record. Okay, that was really fun. Guys, HandyCon was awesome. This was a great week. All the talks have been really awesome, and the hosts have been great. I just had a great time, and thanks everybody for a great week, and I hope you're all inspired to build cool stuff on Handshake. Fist? Cool. All right, thank you.